Hello and welcome back to the series. My name is Piyush and this is day 11 in 30 days of AWS Terraform. I'm sure you have been following the series in the same sequence as it have been uploaded, meaning from day 1 onwards, and day 0 has some important information about this 30 days of AWS Terraform challenge, how to participate in that and how to submit your assignments, results and everything to be eligible for the gift at the end of this series. Okay, so in this video we'll be covering into Terraform functions. So it's a long topic, there are so many things to cover, so I have decided to divide this particular topic into two different videos. So we'll cover half of these functions or whatever we could in this video, and rest will be covered in the next video, day 12, which will be uploaded tomorrow as we are uploading in the same sequence. So yeah, if you are new here, hi, my name is Piyush and cloud and DevOps is what I do all day long. I have been in IT for past 13 plus years and I am teaching cloud and DevOps to everyone for the past 4 years through this channel, through blogs and through many other mediums. Like I have a Udemy course, I have published a book as well, as you can see it over here. Yeah, so this is what I know and this is what I love sharing with everyone. So without wasting any time, let's move ahead with the video. So before understanding Terraform functions, if you are a beginner, I'm assuming you are someone who is not from a programming background, right? So what exactly is a function? Let's forget about Terraform function. Let's just understand what exactly is a function. Okay, so in simple language, function is something that makes our life easy. Okay, how would it make our life easy? It makes our life easy by letting us reuse the code again and again. For example, let's say you have a simple task, right? So you have to add two numbers and provide the results. So you will start writing a program something like a equal to 2, b equal to 3, and c equal to a plus b, and then oops, what happened? And then finally you will do print C. So this is something that you would do in a typical programming language. Like syntax could be different and like the values could change, but this is something that you would do to provide the result, to print the result of a sum of two numbers, right? So you just write this code. This is a 4-line code, or you can write this in 1 line, whatever, right? But that's not the point. The point is, if you have to do it once, you will just write these 4 lines. But how about if you have to do it multiple times, let's say 10 times? So what you will do, you will write the similar code 10 different times. This is not efficient. This is not the right way of do programming, even though it's not considered a program, but still it's not really the right way. And it will take a lot of memory. It will take a lot of time for the execution. In a way, it's not a good choice. So what you can do instead of copying these multiple times, you can just write it once. Okay, so let's say you have written it once and you wrap this inside a function. Okay, so consider this as a function. These are the content of a function, and you just name this function something, let's say sum. Okay, and whenever you have to provide the result of sum of two numbers, what you will do is you will just call this function using sum, and that's it. So let's say you have to provide, I'm not getting into specifics of any programming language, but let's say you just have to provide the sum of 2 plus 3. So you can just call sum and you can just pass the value 2 comma 3. This is value A, value B. The value will be captured by this function and then print the result C. Okay, and like return the result C and so on. And you can do this multiple times. So now let's say if you have to execute the values 4 different times with even different set of inputs. So instead of 2, 3, let's say 1, 3 or 2, 2, something like that, right? So you don't have to write these 4 lines again and again. You just wrote it once, wrap that inside a sum function, and then you can just call that function with different value, right? So this is why we use function. This is what exactly is a function in a very basic simple language. Okay, Now you probably already know, and we have covered this as well earlier, like Terraform is not a programming language. Like it's HCL, which is HashiCorp configuration language, right? It's not a full-fledged programming language. It's a configuration language. That means it provides you similar functionality of a programming, but you cannot do a lot of things. Like it does not have classes, it does not have objects, it does not have oops, and like lot more concept. It does not provide you all the flexibility of a programming language. Still, it helps you do what it is famous for, which is infrastructure provisioning or infrastructure as a code. Now, because this is not a programming language, why did I mention it's not a programming language? Because unlike in the programming language, you cannot create your own function in Terraform, right? So no custom functions. You can only use inbuilt functions. Okay. In a programming language, you can create as many as function you want. You can use inbuilt functions as well as you can create your own functions. But in Terraform, because it's not a programming language, you cannot create your custom functions, but you will have a lot of inbuilt function provided by Terraform that you can use wherever you want. Okay, so these functions are categorized broadly into these categories, right? So there are validation functions, lookup functions, date and time function, type conversion, collection, numeric, string, and file. Okay, so all these functions are categorized into these, and inside each of these categories there are multiple functions which we'll be covering in this video. So we'll cover with the help of Terraform console first, and then we'll do the assignments that will be given in the GitHub repository. I hope it is making some sense now, but it will make more sense when we do the demo. Okay, so let's start with it. So first, what you have to do is you just go to your Terraform terminal, whatever you have been using. I'm using VS Code since day one of this video, so I'm gonna use the same. And you just write Terraform console. This will open a console prompt like a shell inside the shell, but this shell is like a Terraform shell in which you can execute Terraform commands without writing the Terraform files, right? So you can execute the functions directly over here. All right. So yeah, and you don't have to install this Terraform console separately. It's built in within Terraform. So if you have installed Terraform already, you should be able to use this. Okay. So now let's start with some basic functions. Okay. So there are some string functions, right? Like there is lower and upper function. Okay. So let's start with the first function. There are few functions in string functions. So we have, discussed over here, there are multiple type of functions. So we'll start with the string function. Okay, so there are upper function and lower function, which are the most common ones. So first let's add a string, okay, inside double quotes, because if it's a string, it has to be enclosed inside double quotes. And let's call it hello 30 days of AWS Terraform. Okay. And now we have enclosed this inside double quotes and inside square bracket. And now we can add the function name in front of it. So let's say upper. So what it will do, it's a function that will convert this string inside this function into uppercase. Now, if you remember when I talked about calling the function by passing the values, right? So we have passed value 2, 3, 1, 2, and so on. When we were calling the function, we are doing the same over here. So instead of doing sum 2, 3, in this, the values that we are passing to this function is a and b, which is in numeric form, right? Because this function expects the values to be passed in the numeric form. So instead of passing values to the numeric form, now because we are using a string manipulation function, we are passing the value in a string format. Okay, so what it will do, what this function will do, this function, which is an inbuilt function named upper, we are calling this function over here in the definition of the function where it has been defined. So it has some internal logic which will convert all the characters in this string into uppercase. Okay, so let's hit enter, and here you will see now it converted everything to uppercase. Now the same way, you just copy this because everything is in uppercase. Now if you do lower and add this inside the string, Now this will change it back to lowercase because now we are using a lower function. So that's the string function, and this is how you call. If you understand this concept, maybe watch this section twice, because if you understand this concept, the concept of function will be clear, at least from the Terraform perspective. Okay, that's the most common one, which is upper and lower. Then we have trim function. Trim, what it will do, as the name suggests, it will trim the blank spaces inside the string. For example, let's say I've added one space first and then I've written, let's call it AWS and then one space after it. So if I do that and hit enter, oops, it says not enough function argument. Trim expect 2 arguments. All right, so I'm doing something wrong. Maybe because we have to provide value as well, like how do we want to trim it. Okay, so trim is not just to trim the blank spaces but to trim anything. Okay, so the way it works is, the first argument is the string, and then we have to provide the second argument as well, which says trim the occurrence of a particular character. For example, if we have to trim the space, we have to provide space as the second character. So let's try it again, and let's do comma, and then let's add a blank space. I'm not sure if it will work, but yeah, it did not. So let's add a blank space in double quotes. Yeah, now it worked. Okay, so as you can see, this is the string which has a blank space in the beginning, blank space at the end, and with comma we provided a substring. Okay, substring has the character which is space, so it removed space from the string. Let's take another example of this. Okay, instead of the blank space, let's add something else. Let's just trim the F word from it. Okay, so from that, let's just add F over here. Now I've removed all the spaces, or you can just keep the space so that it will show you that space is not trimmed if it's not in the substring. Now string is space AWS and the substring is F. So ideally it should only remove F from this string. So if we hit enter, you see AWS it removed the F. Okay, so and space is also there. So that's how trim works. The next one is replace. Replace works as the name suggests, it replaces occurrence of a character with additional characters, right, that we provide. So the way it works is, let's say replace hello world, this is the string, and then we provide source character that we want to replace. So let's say we want to replace space with hyphen. Okay, so inside double quotes is the space, comma, the third element which is the second string, and let's add it hyphen. Okay, hit enter. Now hello space word becomes hello hyphen word. So what we did, we provided a string. First substring is the character that we want to replace, and the second substring is the character that we want as the new character in place of the old one. So that's how replace works. The next one is substring. So substring works like this. So you provide the string, okay, and you are saying comma 0, comma 3. So what it will do, it will check from the 0th element, okay, and it will only trim till third element. Okay, sorry, 0 to 3, that means first, second, third element. Okay, so that's how it will do, first, second, and third element. It will cut only that part. So that's again one of the string manipulation function. The next is numeric. So numeric, as the name suggests, it will work on the numeric. So like the sum function that we were looking into. So there is an inbuilt function for sum as well. So sum 2, 5. Oh, sum is not there actually. So there is no sum function in Terraform, but you can do max, min, and absolute. So let's start with max. And you can provide multiple numbers like max, 12, 1, and it will provide you the max out of all the numbers. Similarly, we have min, so 5, 12, 1, and minimum should be 1. Okay, and then there is absolute. It will provide you the absolute value of the numeric. So minus 42 becomes 42 because that's the absolute value. Then we have collection functions. Okay, so I'll just write it down, collection. Okay, it will show you the error because I was just trying to show you that from here we are starting the collection. Now I see why it's a bad idea, but I think you got the point, right? So collection works like this. So you provide length, and inside the brackets you provide a list. So let's say a list of element 1 2 4 3 4. Okay, you provided the multiple elements in a list. So the length function will calculate the number of elements inside this list. Okay, so there are 4 elements. So if you could just add, like, instead of 4 you add 2, it will still show as 4 elements, right? Then we have concat. Concat function is for concatenation. It will concatenate multiple values into one. So if we want to add 1 2 and then comma 3 4, so we are trying to concatenate two lists. Okay, so it becomes 1 2 3 4 inside one list. Okay, so that's one list. Now if you want to use merge, so there is a merge function. As the name suggests, merge works similar to concatenation, but in a way it works on a key value pair. Okay, so let's say concatenate works on list or string, on numeric as well. Let's see if concatenate work on string as well. So let's say concat, and inside this you provide hello, and another element is world. Yeah, it does not work on list. It says all argument must be list or tuples. We got string. Okay, so it does not work on string. So the next is merge. Okay, merge works on key value pair, which is tuple, set, and so on, right? Set, not set, which is tuples in this case. So let's start with a equal to 1 and b equal to 2. If we try to merge these two, we'll say inside one single map it says a equal to 1, b equal to 2. Okay, now the next type of function is, and like I'm just going through it with the help of the simplest example, like how this function would work if these were not in Terraform. Okay, but I will explain each and every function inside Terraform as well with the help of Terraform file, so don't worry about it. Let me just walk you through it, a few more functions, and then we'll see in action in Terraform. Okay, so just be with me. Now the next one is type conversion. Okay, so type conversion, as the name suggests, it converts one type to another. For example, if we want to convert list into set, so how do we do that? To set. Okay, and just provide the values of a list. So let's say A, B, and A. Now, if you remember, when I was covering type constraint, I mentioned that list can have duplicate values, but sets don't have duplicate values. So now, because it's a list, currently it has duplicate values like A and A occurrences twice. But when we convert it into set, the duplicates will be removed. Okay, so if I hit enter now, you see when it converted into set, now it only has A and B because the duplicate has been removed. So that's how we know that it's been converted into set now. So that's one example of type conversion function. Now another is, let's say to number, and let's say there is a string with the number something 23. Now we need to convert it into a number. Now you could say like 23 is a number. Why are you saying you're converting it into a number? 23 is a number, but when we enclose that into double strings, double quotes, it becomes a string. Everything that goes inside double quotes is a string. Okay, so that's why Terraform is considering this as a string, and when we put to number function in front of it, it becomes a number after this. So now 23 is a number. Okay, the same way if I do to string, and if I do, let's say 23 without double quotes, now it will return the value in double quotes. That means now it become a string. That's type conversion function. And then finally we have date and time function. So let's say timestamp. Timestamp shows you the current time in a predefined format. Now if you want to change the format to something as per your requirement, what you can do is you can do format date. So format date is another function, and then you can provide the format in double quotes. Let's say dd YY or YYYY, whatever format you need, comma timestamp. So what we are saying, use the timestamp function to print the current time, which is this one, but then change that time into this format, DDMMYY. So if I hit enter now, it will show you DD, MM, and YY. Okay. So these are like a few examples of these functions. Now we'll move ahead and see these functions into Terraform. How do we do that? All right, so let's like always, first I'm gonna exit Terraform console and let's see where am I. Am I in this folder? So let's just make a copy of day 10 folder and create day 11 folder. Now I'm gonna go inside day 11 folder, and from here as well. Okay, let's just empty the day 11 folder file, the main.tf only. Okay, and now we're gonna start with some examples. So I'll just open the assignment on the side screen. Okay, so first is, let's create a variable. So inside variables.tf. Okay, I'm gonna remove everything. So let's create a variable name project name. Okay, and inside this I'm gonna add a default name, and I think this should go up. Okay, so now variable project name, and this is the project name, project alpha resource. In this, alpha is in uppercase. So in this function we'll be converting the project name into lowercase using the lower function that we have already seen, but now we'll be doing it in Terraform. Okay, so inside the main.tf, let's create a locals. Okay, and inside locals what I'm gonna do is I'm gonna create formatted project name is equal to, if you remember, we have to convert that into, let's say, lowercase. So we'll start with the lower, and when you do that, so VS Code, if you have Terraform extension installed, it will show you the suggestion like this is the format lower, and then it expects the string. So str string, that means it expects the string. So now what it is saying is inside lower, what is that, var dot project name. Okay, and now we have to print this value. So let's go to outputs, and inside output, let's create output variable and call it formatted project name. You can use the same name because that was the input variable, this is output variable, they can be same. And add the value is equal to locals dot formatted project name. Okay, and if I do tf init, oops, I don't have alias set, so let's set the alias. And if I do tf init and then tf plan, okay, it is throwing some error, has not been declared, locals dot formatted project name has not been declared. Okay, so let's see, main.tf formatted project name is this. Okay, and over here is variable is project name, and output is equal to, maybe we cannot directly print locals. Let's see, I'm not sure. I mean, now it is showing that. It is throwing some warning, but still, yeah, still, if you see, the output will be formatted project name equal to project alpha resource. Now it is in lowercase, and you can verify that by using tf output or tf show output. Let's see, no outputs found. Maybe because we did not run Terraform apply yet. So that's okay. Let's use Terraform output formatted project name, the output variable. Okay, so it says please define an output with the output keyword to run Terraform refresh for it to become available, because we have not run the Terraform plan even once. So if I do Terraform refresh, and after that if I run Terraform output, now it should show the value. Terraform output project formatted project name is project alpha resource. Okay, so it has converted uppercase to lowercase. Now let's make one more change in the same file. Instead of now for making it lowercase, just the lowercase, let's add one more thing. Let's replace the space bars into hyphen. So what we can do that inside this function, replace, add the replace, and that's the string. So it shows you the syntax. So replace and then first string, then substring, and then the replace string. Okay, so the first is project name, comma, I'll add space, and the last string is your new string, which is hyphen. Okay, and let's close this. Okay, I think there is a syntax error over here. Okay, all right, so this is how it would look like. Now let's do tf output again. Okay, it did not do anything because we have not run Terraform refresh yet. You see, because we have not applied the changes, that's why it is not making the changes. It's not reflecting the changes. So if I do Terraform refresh, and now it is showing the output format correctly, like spaces has been replaced by hyphen. So that was like how you can do lower, upper, and replace, and you can use multiple functions inside the same line. Like how we use, first it will execute the inside function, which is it will replace the spaces with comma, and then it will convert everything into lower, right? So how it will work, so let's say first replace function will work. Okay, so in the first iteration it will execute the replace function, and how it will do that, it will convert this, let's say hello world. This will be converted into hello hyphen world, and let's say it was not like this, it was hello world. So first this will be replaced by this, and then this entire string will be passed to the lower function or upper function, whatever, right? So lower function will have this string. Now what it will do, because this is a lower function, it will convert this into hello world like this into lower. So this string will become this string after we apply two different functions, replace and lower, inside the same one. All right, so that's how it's done. Now let's do a quick time check. We are at 31 minutes mark. Let's continue with this video for some more time, maybe 20-25 minutes, and then we'll see. Okay, the next one is let's use the merge function. Okay, so to use the merge function, first let's add a resource over here. Let's create an S3 bucket. So resource and AWS S3 bucket. Is this the correct resource name? We'll see. Not enough labels specified. Must block have two labels. Okay, we'll see. Name is equal to hello tech tutorials with Piyush. I think there is some issues with the resource name, so let's go and check AWS Terraform provider documentation. Let's go inside this registry.terraform.io and search for AWS S3. Where it is, where it is, where it is. Okay, all right. There are a lot. Let's use bucket. Yeah, AWS S3 bucket. Oh, that's the data source. Not this one. AWS S3 bucket. So resource name is correct. So resource AWS S3 bucket. Oh, we did not provide the name of the resource. Why I'm making the same mistake again and again. Okay. So let's provide the internal name. Let's call it first S3. And inside that, we have name of the bucket and, oh, not the name. The field name is inside its bucket. Okay, so that's the only mandatory field. So let's add bucket over here. And over here, let's add tags. So tags are, let's say, environment is equal to dev. Okay. So that's the basic AWS S3 bucket. So if I run tfplan, okay, yeah, it says one plan to add, which is an S3 bucket over here with the tag environment equal to dev and with the name that I've provided, which is Hello Tech Tutorials with Piyush. Right, now let's see how we can use the merge function. So go inside variables and let's have these two variables created. Okay, so there are two variables. Okay, and we have not provided any type, so it will select the type automatically. It's a key value pair, so no, so you know it's a map. Okay, and it has two tags. One is company, which is tech corp managed by Terraform. That's one variable which is default tag, and then there is another variable which is environment tag, and it has two more key value pair, which is cost center and environment. Now, there are some cases when we have to merge these two variables together to form a new variable. We can create a local and merge these two together, or if we don't have many occurrences, then we can do that directly over here. So inside tags, wherever we have tags, we can just use tags equal to merge. Inside merge, you can just merge two maps together. So var dot default tags comma var dot environment tags. Okay, that's it. Hit save, and if I run tfplan again, so now if you see, I'm looking for the tags field. So you see here is the tag. So the tags are inside the bucket. Now we have 4 tags because we have used the merge function and merge all those tags together. So it is used to merge two maps together. So this is one map, this is another map. So we have merged both the maps together inside tags. Now you can do that over here, or you can just do that, like I'll just cut it, and inside locals I have created a new tag and let's call it new tag. And inside new tag, we can use merge function directly. And now what is the benefit of doing that in locals? Now we can directly access the merge value of these two maps with the help of just new tag variable. So now over here we can just do not var locals dot new tag, and that's it. It will do the same thing. But now we can do that at multiple places. Now if we want to use the same merge tag in multiple location, we can do that. And now it is throwing the error again. It's just something like, I don't know why it is showing that, but maybe we can use it local instead of locals. Yeah, so while defining it, we use locals block, but by when we use the value, we use the value with local dot. Okay, so over here, if you can see, the tags, it does the same thing, right? It has these 4 tags. So we have merged it together, and we have merged it inside a local variable, and then we have used that local over here inside the tag. So that's the second assignment. The third one is which is bucket naming. So let's say we have the bucket name over here. Variables. Inside variables, I'm gonna add the bucket name. So bucket name is something like this: project alpha storage. There is a space with caps and spaces, and now we have to do the formatting of the bucket name. So instead of this, first we'll do var dot bucket name. Okay, let's see what it's gonna print. Okay, so the bucket will be created with this name, the one that we have provided. It has spaces, it has special characters and everything. I mean, it will fail when we run Terraform apply because S3 bucket has some like conditions, like the bucket name should not be these many characters long, it should not have special characters or so on. So it will fail. Also, I don't think it should have a capital P. So we need to make sure that we do the validation before applying the changes. So what those validation is, there are multiple validations. So first we have to convert the bucket name into lowercase. Okay, so let's do create a local. So let's call it formatted bucket name. That's the name of the variable, and let's do it into lower first. So lower var dot bucket name. Okay, that will change the bucket name into lower characters. What else does it have? It should not have more than 64 characters. That's the other limitation of the S3 bucket. So what we can do is we can trim the characters after 64. Okay, so we can use substring function. So substr, and inside that we'll just add 0 and 63. So in fact, let's see what should be the value. AWS S3 bucket naming, general purpose naming loon. The bucket name must be between 3 and 63 characters. Okay, and it can consist only lowercase number, periods and hyphens. Okay, so that's the basic requirement of an S3 bucket. So what we are doing, we are saying just maximum is 63, minimum is 0. You can do minimum as 3 or whatever, but let's just do 63. So now first it will change it to lowercase, then it will set the maximum length, and then it will replace. So we need to now replace the character. So let's use the replace function over here, and let's move that to the next line inside replace. So we have one over here, 1 1. Okay, and let's do spaces, remove the spaces and this. Okay, let's first try it out. Maybe we are making some syntax error. I don't want to make it hard to debug, so let's do that first. Okay, so what should be the bucket name with just this? Let's see. Okay, so now it has removed, or it did not remove spaces yet. Yet spaces, I can see the spaces over here. Or if I do tf refresh, I don't think it will make any difference, but let's just try. It will only make the changes to the output variable, I believe. Let's see. Yeah, spaces are still there. Why spaces are still there? It shouldn't be, because we have used replace. Okay, let's add one more replace first, and then we'll see. Now we also need to replace this as well. So let's remove these special characters as well. Let's use replace in front of everything, and over here I'm gonna add one more, which is this comma this, and let's close this over here. Oops, no, I think it's already closed. Let's run tf, not refresh, sorry, tf plan again. Tf plan. Okay, still there. Semicolons are there, and also it should be lowercase. Yeah, so formatted bucket name we have changed, but we have not used it over here. Okay, that was the mistake that I'm making, because it is taking the bucket name from here, from var.bucket name, right? But we are making changes in the locals. Okay, so let's change it local dot formatted bucket name. Now it makes sense. Okay, tf plan, and now the bucket name should be changed to the way that we want, which is this one. Okay, everything is in lowercase. spaces has been removed, and exclamation marks have been removed. If you want, you could have converted spaces into hyphens as well, because hyphens are supported inside the bucket name. So that you could have done, but like that's how you use multiple functions together. And this is like a real use case, like why do we need to use these functions? Like inside this variable we have used substring, lower, multiple time replace, so that we make sure that the bucket name should be as expected. Even if someone provides the wrong input, it should be able to autocorrect, and the Terraform command should not fail, right? We are handling it like it's a sort of error handling that we are doing. Okay, so that's a good use case. The next is we're gonna use some other functions such as split, join, and yeah, for expressions. So let's see. I'm gonna create a security group rule. Was it there in day 10 video? Instead of actually using this on the security group, let's try to keep it simple, because otherwise it will be overwhelming. So let's do that. Let's create a variable with multiple ports. Okay, inside variables.tf, I'm gonna create a variable called allowed ports, and it has multiple ports. Now if you can see that all the ports are comma separated, but everything is inside double quotes, that means it's a string. Okay, it's not a list, it's a string. Now first we have to separate it into a list, and then we have to iterate it through the list and do some modifications on that. Okay, so let's go inside our locals. Okay, so we have formatted project name, new tag, and this. So let's create another local over here. Okay, and let's call it port list. So now what we are doing inside port list, we have to first convert that into a list, and we can do that using split function as well. So we can use type conversion, or we can use split as well. So what we are saying, split. Now we have to provide, as you can see over here, we have to provide a separator and then the string. So inside the split function, first the separator, which is comma. Okay, inside double quotes, comma, comma, and then the list is what, var.allowed ports. Okay, so now this port list will become an actual list with multiple ports, and all of these are ports. Now we create another local, which is sg rules. Okay, and inside sg rule we create because we have to iterate it through the list, right? It's a list now, so we have to iterate it through the list. So we can use the for expression. So there is for each, which we have seen earlier, but then there is for as well. So what we can do is for port in, okay, port in local dot port list. I'm gonna explain it to you, just wait. Okay, so port underscore list. So now what we are doing over here, we are saying start a counter from inside this port list. So let's say this port list have 4 different values. It's a list. The list have 4 different values. So we are saying create a counter variable with the name port, and port will iterate from all the elements inside that list, from element 0, 1, 2, so whatever the end of the list is. Okay, so we are iterating it through the values in the list, and then colon. So this is the syntax how we use for loop inside Terraform. Okay, and then we'll put everything inside curly braces. Okay, so for loop and then colon inside curly braces. So let's say we are setting name is equal to colon port hyphen dollar port. Okay, so now you see 2 ports over here, so don't get confused. The first port is the string which we have just entered, and because this port has a $sign in front of it, so this is this port counter. So what we are saying, port hyphen 8080, port hyphen 80, port hyphen 3306. So the name of the security group rule will be port hyphen the port name. Okay, and this particular syntax, if we have not covered it earlier, it's called interpolation. So when we are accessing any variable inside Terraform, we can just directly do var dot something something, right? But when we are concatenating it with another string inside a string, then we have to use the variable inside the curly braces, and prefix is dollar, so that it can first convert this into value, oops, and then add it to port. So it's called string interpolation. Okay, so the name will be this, and port is equal to port. Okay, this is the direct port, we can access it directly. And then we have description. So description could go something like allow traffic on port, again the interpolation dollar port. Okay, so yeah, that's why I did not use it on the actual security group rule, because I don't want it to be more complicated than it already is. So let's do a quick recap of what we did. Okay, so we created a variable with multiple ports. Let's see it over here. So there are multiple ports, but it's a string because it's separated by comma, and then it has double quotes. So allowed ports is the variable name. Now inside main.tf, what we did, we first split that variable with comma as the separator, okay, and passed the string over here, and we split that would convert that into a list, and we added that into port list, which is list. Okay, and then we have created another local with the name sgrules and created a for expression which will iterate inside all the elements of this local port list. Okay, and then it will set some variables. Okay, the first variable is name, port, description. Okay, and let's create the output variable as well to see the values. Okay, so output, and output name is, let's say, port list value is equal to local dot port list. The same way we can do output on sgrules, and value is equal to local dot sgrules. Okay, and let's do tf plan. So it should show the value. Let's see what it shows. So go. Okay, so now if you see, these are the output variables. So port list is now a list with 844380803306, and sgrules, which is, as you can see, it's now become a map with multiple elements. So the first element is this. Okay, allow traffic on port 80, where this was the port, and over here this was the port, over here this was the port. Okay, so it has iterated through all the values, which is 844380803306, right? So this becomes the first element with 80, this becomes the second and third and fourth. Okay, so this is how it will work when it comes to where it is. Yeah, so this is how you would use for expression, split function, and this is how you will iterate it through multiple values. So now over here we did not define the variable type over here as well, but the way we split it, it automatically gets it that yeah, it's of type any, but the way we are entering the value, it become a list. Similarly over here, it, because we are iterating in a list, but then we are using that values inside a map, right? So that's why it become a map with multiple values, key value pair, and so on. Okay, let's move ahead. The next one is a lookup function. Okay, let's see how the lookup will work. So we have a variable over here. This is the variable. Variable is instance sizes. Okay, default values are dev equal to this, staging equal to this, prod equal to this. So we are basically setting up in advance, like if it's a dev environment, use this instance. If it is staging environment, use this. If it is a prod environment, use this environment. But how would we add the logic over here, like which environment to use, what to be do? Okay, so that's why we are using the lookup function. So inside locals over here, let's create instance size as local. Okay, and over here, because we need to use lookup function based on the environment, right? So if you see, sorry, add lookup, and it will show you the expected values for lookup function. So if you see, first is the input map, which is like the input values that you are providing. Then there is key meaning what value to look for. And then there is default is if it does not find anything, what value to use. Okay, so the first is input, which is var.instance sizes. Okay, second is based on environment, because we are looking that set the instance size based on environment, right? So that based on thing is environment. So var.environment. Okay, environment is not a variable that we have set, so let's set the variable environment as well. Variable environment, and let's set a default value of dev. Let's go back, right, var.environment, and then set a default value. If it doesn't find, then use t2.micro. Okay, so now if I use that's instance size, so let's create an output variable as well. Output and instance size value is equal to local dot instance size. Okay, so let's run tf plan. Okay, let's see the value. Instance size is t3 small. Okay, let's see why did it take t3 small. Main.tf lookup, we are doing size into blah, 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 environment, and the values were defined inside variables. So if the environment is dev, it should have been t2 micro, but where we are using staging. Why it is taking staging? Because we might have it in tf-vars, and if you remember, tf-var takes the precedence over the default values. So over here it was staging, that's why it was taking staging. If I do it over here as prod, okay, and if I run the tf plan again, so the value should have been, let's see, t3.large as per prod. Okay, let's see, t3.large, right? And if I do anything like either dev or anything except these three, so it should take t2.micro because that's there in the default. Okay, so let's say production. If I do that and if I run tf plan again, it should use t2.micro because that was the default value defined in main.tf, where it is. Okay, over here you see this is the default value t2.micro. So over here instance size is t2.micro because we have used the value as production, which is not there inside this value, right? So that's how lookup function works. Okay, and yeah, I think this is enough for this video. We are on 1 hour mark. Yeah, we have crossed 1 hour, so I think this should be more than enough for today. Make sure you do the practice, make sure you check the assignments given in the GitHub repository. It will be the same, and you can practice it yourself to understand it better, to get your hands dirty. Otherwise this will not be much helpful. Okay, So do that, and I will see you tomorrow from assignment 6 onwards. So thank you so much for watching. I hope you had a good learning experience.